Good day, everyone. This is the second video of this series and our first chapter anyway. Now, what's the topic we'll be looking at in this series? In this chapter, quantities and measurements. As we know in physics, physics is about measurements, is about quantities. Now, what are we going to be looking at on quantities and measurements? In this chapter, we shall look at the following. We are going to look at fundamental quantities and derived quantities. What we mean by fundamental quantities and derived quantities. Then we are going to look at measurements generally, the units of conversion and dimensional analysis. So let's start with fundamental quantities. When we say quantities, what do we mean? Now, in nature, we have two kinds of quantities. We have what we call the fundamental quantities, and we have the derived quantities. These are the two quantities in physics. Now, when we say fundamental quantities, what do we mean? Even fundamental itself means something. When we say fundamental, what does it mean? It means basic. So when we say fundamental quantities, we are simply saying basic quantities. So we can safely divide fundamental quantities as those basic quantities from which all other quantities depend on. Fundamental quantities are the basic quantities that all other quantities depend on. Now, when we say fundamental quantities, we are simply saying quantities from which all other quantities can be derived. That is, those quantities are fundamental quantities. And in nature, we have 7 fundamental quantities. Let's look at them. We have 7 fundamental quantities. Let's look at those 7 fundamental quantities. Now, these are quantities, fundamental quantities, and their units. Now, what are those 7 fundamental quantities? 1, we have length. Length is a fundamental quantity. And what's the unit of length? The unit of length is meter. Small letter m. The second quantity, we have time. And what's the unit of time? The unit of time is seconds. Then we have 3. We have mass. What's the unit of mass? Mass is measured in kilogram, which is kg. The fourth, we have temperature. What's the unit of temperature? The unit of temperature is Kelvin, which is K. Number 5, we have amount of substance. And what's the unit of amount of substance? Amount of substance is measured in mole. We have electric currents. What's the unit of electric current? That is ampere. That's A. Then we have 7. We have luminous intensity. And what's the unit of luminous intensity? That's candela. Candela, CD. So these are the 7 fundamental quantities that we have in nature. From these 7 fundamental quantities, all other quantities get their definition. So, as I've said earlier on, I said fundamental quantities are the basic quantities that all other quantities depend on. They are quantities from which other quantities get their definition. And I said that we have 7 fundamental quantities. We have length. The unit of length is meter. We have time. The unit of time is seconds. We have mass. The unit of mass is kilogram. We have temperature. The unit of temperature is Kelvin. We have amount of substance. The unit of amount of substance is mole. We have electric current. The unit of electric current is ampere. And we have luminous intensity. The unit of luminous intensity is candela. Now, let's move to derived quantities. Now, derived quantities. And what do we mean by derived quantities? Derived quantities are quantities whose definition are gotten from fundamental quantities. Fundamental quantities. So any quantities that can trace its definition, its formula to fundamental quantities, they are derived quantities. So it means that every quantity that are not part of the 7 fundamental quantities listed before, they are all derived quantities. I said we have 2 quantities, fundamental quantities and derived quantities. And the fundamental quantities are 7. So any other quantities apart from these 7 fundamental quantities, they are actually derived quantities. Now, what are the examples of derived quantities? An example is speed. Now, why do you think speed is a derived quantity? The reason is, the formula of speed is distance over time, right? And when we say distance means length. And length is a fundamental quantity. So we are saying length over time. And also time is a fundamental quantity. So it means speed is a derived quantity because its definition is from that of fundamental quantity. Now another example of derived quantity is what? Is acceleration. Let's look at acceleration. Now what is acceleration? Acceleration is velocity over time. And what is velocity? Velocity is displacement over time. And displacement is the same thing as length. So it means length over time, length over time, then over time. You agree with me that length is a fundamental quantity, time also is a fundamental quantity. That makes acceleration to be a derived quantity because the definition of acceleration can be traced to fundamental quantities. Now another example of derived quantity is what? Is power. And now, what is power? Power is force times distance over time. You agree with me that distance is a fundamental quantity since it means length. Time also is a fundamental quantity. Now what is force? Force is mass times acceleration. You also agree with me that mass is a fundamental quantity. Acceleration, as earlier stated, root is from what? Fundamental quantity. So that makes power to be a derived quantity. So we have looked at 3 examples of derived quantities: speed, acceleration, and power.